My wonderful viewers, students at home. Welcome to Success Gate Academy. Let's see what we have today in physics. The topic says inductors and inductance. Okay, inductance and inductance. And here is the question being posed. A 120-volt AC voltage source is connected across a pure 25 millihenry inductor. Find the current through the inductor if the frequency of the source is 120 over pi. That is the question. And of course, in an AC circuit, Xn, which is a resistance because it offers an opposition, Xn is equals to 2 pi Fn. 2 pi Fn. And in this formula, 2 pi Fn, F is our frequency, and frequency is measured in hertz. LO is our inductor. It offers an opposition in an AC circuit called inductive reactance. Inductive reactance is measured in Henry. Okay, and from Ohm's law, we have that the voltage across a metallic conductor is directly proportional to currents. So, since this, we will adopt a relationship here with Ohm's law. You agree with me that Vn, which is the voltage across an inductor, is equals to I, the root mean square current, times Xn, which is our resistance called inductive reactance. So I will also have this formula Vn equals to I Xn. This is the second formula I will also use here, or the question demands. This is for opposition. It's called inductive reactance, and this is for the voltage source of an inductor. So, coming to the question, a 120 volts AC voltage source, our potential difference is 120 volts. It's connected across a pure 25.0 millihenry inductor. Our inductor here is 25.0 millihenry. Okay, and the unit of inductor, like I told you, is Henry. So therefore, L is equals to 25 times. The unit milli is equals to 1 over 1000. So L is equals to 25 times 1 over 1000, because this should be in the unit of inductor, which is Henry. Okay, so our frequency from the question is 120 over pi. 120 over pi. Frequency is in hertz. So we should substitute with what we have here. Xn is equals to 2 pi Fn. Of course, I have my inductor, I have my frequency, so I can get my Xn with this. So therefore, substituting for the value of Xn is equals to 2 times pi times the frequency, which is 120 over pi, times the inductor, which is 25 over 1000. Because when 25 multiply 1 is 25. So we have this value 25 over 1000, of which pi can strike out pi. So I will have Xn equals to 2 times 120 times 25 over 1000 is 0.025. Now, when you punch the value of this in your calculator, you believe me that Xn is equals to 6.0 ohms. It's ohms because it offers opposition, and of which you know that every opposition or resistance are measured in ohms. We are not done yet, because the question is asking of the currents. The question is asking of the currents. But what we get is inductive reactance. So for us to get the current, we are giving voltage across the inductor as 1 120 volts. So therefore, the relationship, which is our second formula, is now equals to Vn equals to Ixn. And my Vn is 120 voltage supply, which is equals to I times the inductor, which is the inductive reactance, which is 6 ohms. So I will divide both sides using the coefficients, which is 6. So my current here is equals to 120 divided by 6. And when 120 divide 6, the answer is 20 amps, because the unit of current is amps. This is where we got the conclusion for here. Any question in inductor and inductance can either be solved with this formula, which is my equation 1, or this formula, which is my equation 2. Thank you, wonderful viewers. See you. Don't forget to share, comment, and subscribe. Thank you.